Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 6.5, solving absolute value equations. So we have a warm-up first on some review problems. Please try it yourself as usual so that you actually get some practice with it. So graphing lines are definitely going to be on our exam. We'll need it next semester, and you'll need it in all of your high school math classes that you take. So you want to make sure you get really good at it. So if you're having some trouble remembering how to do number 1 and 2, you might want to say, oh, I need to go back and maybe look at Khan Academy and do some extra practice here. Okay. All right, so number 1 is in point slope form. Remember that's y minus y1 equals my slope and x minus x1. So the x coordinate of the point that I see is 1. And the y coordinate is actually -2 because this is really y minus -2. Okay, and then our slope is 2/3. So we put a point at 1, -2. That's down here in the fourth quadrant. And then from there we go up 2 and right 3 to get our next point. So remember the slope tells us the steepness of our line, which is between every 2 points you should be able to go up 2 and right 3. Okay, and there's our line. And we'll go ahead and label our line. So y plus 2 equals 2/3 x minus 1. All right, our second one is in slope-intercept form. That's y equals mx plus b. And that means that our slope is 2/5. And our intercept, the y-intercept, is 0, -2. That's the place where the line crosses the y-axis. And remember, b is our y-intercept. So we put our first point at 0, -2. And then our slope says go up 2 and over 5. So the steepness of the line is 2 up and 5 to the right. That finds another point that's going to be on our line. And then we can draw our line through those 2 points. And we write y equals 2/5 x minus 2. All right, solve and graph each compound inequality. So our first one is an OR. So we just saw each side separately and graph them on the same grid. So this will be x is less than 1 or x is greater than 5. Remember, when you divide by -4 to both sides, it's going to flip the inequality sign from less than to greater than. All right, so we'll make our own little grid. Here's 0, 1, 2, 3, 4, 5. We'll put our first point on 1. And it's not filled in because there's no equal to bar on x less than 1. And less than 1 are all the things down here. And greater than 5 gets an empty circle on 5. And greater is all the solutions up here. Remember, OR is the union of both. That means anything in the left one, the right one, or any overlap. All right, number 4 is really an AND statement. So this could have been written like this: greater than 3 and x plus 1 is less than or equal to 5. But it's much easier to write it as one statement. Okay, then we can see the boundaries on both sides. So they take away the and they write it without the and, using x plus 1 in the middle. So we subtract 1 from both sides to get 2 is less than x. And then we also have to subtract it from the right-hand side, and 5 minus 1 will give us 4, so less than or equal to 4. So we can see that x is in the middle here, so this is our intersection. This is the intersection of the 2 graphs that we wrote out separately before. So this says 0, 1, 2, 3, 4, 5, that my x falls between 2 and 4. Notice the 4 is filled in, and that's because we have the equal to bar on the 4. So the intersection is stuff that makes both sides of the statement true. So what do I mean by both sides? That means they make this statement true, and they make this statement true at the same time. So it's only the intersection, the part that overlaps. So these numbers in here are both greater than 2 and less than -4 at the same time. All right? This concludes our review. Let's flip over and learn some new stuff. All right, so the second page starts off with a definition of absolute value. So the absolute value of a number a is the distance a is from 0 on the number line. Remember, the distance is always positive, therefore the absolute value of a number can never be negative. So let's draw a quick number line here. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. Okay. So the absolute value of -6 means if I'm standing on -6, how far do I have to walk to get back to 0? So 1, 2, 3, 4, 5, 6 units. So the absolute value of -6 is +6. And then absolute value of 3. So that says if I'm standing on 3, how far do I have to walk to get back to 0? 1, 2, 3 steps, 3 units. Okay, so the absolute value of +3 is also +3. So what it does is it takes negative numbers and makes them positive, and it takes non-negative numbers and leaves them the same. So 0 would stay the same, 1 would stay the same, 2.3333 stays the same. Okay. All right, number 3 and 4, you have to remember that absolute value bars are grouping symbols, so you must work out the inside first. So this will become the absolute value of 0. 5 minus 5 is 0, and the absolute value of 0 is 0 because you don't have to walk anywhere to get to 0 on the number line. Okay, and then here will be -5, and this is going to be 5 steps away from 0 on the number line. All right, evaluate the absolute value of x minus 2 when x is equal to -3. So this just says replace x with -3 and then work out the resulting math statement. So this will become 3 minus 2, which is 1. Remember, absolute value is a grouping symbol, so we must do that part before we do the subtraction. Okay. All right, solve the absolute value of x equals 2. Okay, so the distance between x and 0 is 2. Therefore, x should be at 2 or it should be at -2. So let's take a look at this. So here's 0, and we know that the distance is 2 away. So our distance that x is away from 0 is 2 steps. So 1, 2. So x could have been at 2, or if we walk this way, x could have been at -2. And that's where we get 2 or -2. You can also think of it this way, just what numbers should go in place of x? So what should go in here so that we get the answer of 2? Well, okay, well, the absolute value of 2 is 2. So 2 is one of my answers. And the absolute value of -2 is also 2. So -2 could be one of my answers. So in this case, 2 and -2 would both have an absolute value of 2. Therefore, there are 2 solutions. And most of these questions are going to have 2 solutions. All right, so let's try a couple. What is the absolute value of x equals to 5? How are we going to solve this? Well, I know what's in here should be 5 steps away from 0. So the absolute value of x could be, at x in there could have been 5, because 5 is 5 steps away from 0. Or it could have been -5, because -5 is 5 steps away from 0. So the absolute value of 5 works out here. Let's just check. Oh, well, that's true. 5 equals 5. And the absolute value of -5 also works out here. Question mark. Absolute value of -5 is 5, and 5 equals 5. Now, you don't have to show the check, but it's a good thing to do mentally just to make sure that you did it right. So the absolute value of x is -2. It's going to be no solution. Now, you might say, oh, well, it's just 2, right? So, or -2 maybe. So if you try the absolute value of 2, remember that's going to equal +2. So that's not going to work out for me. So when I tried to check this, I would get 2 and -2, and that's no good. Or if I said, well, maybe it was -2, so I'll replace x with -2. This could work out, but oh wait, no, the absolute value of -2 is +2. And +2 and -2 are not equal, so that doesn't check. No matter what number you pick, the absolute value of it could never be negative. Because remember, absolute value takes positive numbers or non-negative numbers and leaves them the same, and takes negative numbers and makes them positive. All right, number 8, the absolute value bars are already isolated on one side, so we can do the same thing. What's in here should have been, oh, let's see. Well, I could have a 10 in there, that would make it true. Or I could have had a negative 10 in there, and that would make it true. So what was in there right now is x minus 2. So x minus 2 should have been 10, or x minus 2 should have been negative 10. If I solve this, I get x is 12, or x is negative 8. These numbers go in here to make the inside of the bars be 10 or negative 10. Okay? So let's take a look at just check one of these just for fun. All right, so if I plug back 12, so I have 12 minus 2 equal to 10 question mark. That's the absolute value of 10 equal to 10 question mark. And that's true, so it did work. And negative 8 would also work. All right. Last one on this page, number 9, we're trying to solve this, and the first thing we have to do is isolate the absolute value part. So that means pretend like this is your x and solve for it. Well, this is a two-step equation. This is 3 times x minus 7. So first I'll do the opposite of minus 7, which is add 7. And then I'll do the opposite of times by 3, because that's 3 times that. So divide by 3 will give me 6. And then we got this absolute value bar part. So just ignore what's in here for a second and say, well, what should that red circle be? Well, that red circle should be 6, or that red circle should be negative 6. Well, what is the red circle? The red circle is 4x plus 2. And then we solve these two resulting equations. So 4x is equal to 4, so x could have been 1. Or 4x is equal to negative 8, so x could have been negative 2. So we get two possible answers here, 1 or negative 2. And if you plug them back in, they will check out. All right, this concludes our second page. All right, on our last page, we have another definition, absolute deviation. So the absolute deviation of a number x from a given value is the absolute value of the difference of x in that given value. So this is what this means. Absolute deviation is equal to the absolute value of x in a given value. All right, so we'll talk about what it really is doing after we do an example problem here. So this says find the value of x that satisfies the definition of absolute deviation for the given value of 10. So our given value is 10 here. So what values of x with the absolute deviation of a given value of 10 with a deviation of 3? So we replace the deviation part with 3. So let's solve this. So this will split into two parts. 3 could be x minus 10, or negative 3 could be x minus 10. And then we add 10 to both sides to get 13, or we add 10 to both sides over here to get 7. So we get these two answers of 7 and 13. So what this is really saying is, hey, find the distance that is 3 away from 10. What are the two numbers that are 3 away from 10? Well, those two numbers are 13. That's 10 plus 3. And the other one would be 7. So these are the two numbers that are 3 away from 10. Okay? And that's all it's really asking us to. Now the definition looks complicated because as the problems get harder, we can plug into this formula as opposed to having to think about it. Okay? All right, so a 2-minute radio ad for local business has an absolute deviation of 0.05 minutes for the minimum and maximum acceptable times a radio ad can run. So we pay for a 2-minute ad, sometimes it's going to run a little long, sometimes it's going to run a little short. And this is saying what's the maximum length allowed and what's the minimum length it allowed. Because they might cut it off early for a song or they might let it run a little bit extra. Okay, so this says, all right, the absolute deviation is 0.05. Notice all of these are in terms of minutes, so we can write an equation with them without having to change any units. And over here we say x minus our given value. The given value is a 2-minute advertisement. Okay, so we solve this equation. We split it into two parts. So 0.05 could be x minus 2, or negative 0.05 could be x minus 2. And then we add 2 to both sides So one possible length, the maximum possible length of our advertisement would be 2.05 minutes. And the minimum length would be 1.95 minutes. That's what happens when we add 2 to both sides here. So find the minimum and maximum acceptable times of the radio ad. The ad could run a max of 2.05 minutes or a min of 1.95 minutes. Okay. All right. You have a follow-up here. As always, the answers are on the bottom. There's no problem about absolute deviation. We'll practice that a little bit more in class next time. But please make sure you do these problems yourself and you have work. Don't come back with just my answers. If you're not understanding how to do them, that's a tip-off that you should rewatch the video and then come back to them again. See you in class next time.